Hey everyone, how's everybody doing? I hope pretty well. Just give me a chat so I know that you can hear me and everything's working okay. Hi there. Got a nice test. Hi Wei, how's it going? Good to see you. All right, looks like we're all good for our workshop today. So that's awesome. This is great. Looks like some other person has sent in a nice chat to me about my MLH fellowship essay workshop last local hack day. That really means a lot to me. Thank you so much for that. I'm super glad that it worked for you, and I wish you really good luck the next time you apply. Okay, someone writes, should this be a continuation of part 3? It's actually somewhat different than part 3. In fact, I don't think you necessarily need to take parts 1 through 3 to understand what we're going to do today. It's pretty much like almost its own workshop. So with that, let's just get started and I can show you exactly what I'm talking about. So, all right, great. So it looks like everything is working perfectly. So welcome everyone again to the workshop. My name is Steven. I'm here to lead this session and also to help you learn something today. Actually, before I continue, Wei has given some good advice. Yeah, Wei is a great person to talk to about the fellowship. Definitely more knowledgeable than I am. Anyway, living in California right now, and my favorite programming language and tool is Python and Project Jupyter tools, which are really great for science. So the table of contents today, we're going to start by a welcome for localhost. Then we're going to do an introduction to game programming. Then we'll do rock, paper, scissors, build an AI-based opponent, and then a quiz and some next steps. So starting with welcome to localhost, actually Major League Hacking's mission is really to empower hackers. And so if anyone in the chat has been to a Major League Hacking event before or anything like that, feel free to give a little shout out there to maybe what you did, open up some of the opportunities for some other folks to see what we offer. Basically today, though, we're going to focus on a particular workshop that will let you get some skills for the next time you're at a hackathon or trying to do coding in general. We're going to learn about games and how some game AIs work. And then we'll put together what we learn to make a rock, paper, scissors opponent. So moving on now to the game programming. If anybody wants to give us their favorite game or what makes games fun, please send a chat to let us know. Would love to hear your advice. Any comments you might have in the Twitch about your favorite game to play and why you think it's fun. One person asks, is this a session on reinforcement learning? That's a particular type of machine learning, not necessarily all AIs rely on reinforcement. Actually, I don't think today we're going to cover reinforcement learning, unfortunately, as far as I can remember. Last time I looked at these slides. But yeah, definitely. Looks like someone says that their favorite game is CIV3. I've never played that game before, but great balance. That's awesome that you feel that there might be some good balance in the game mechanics. That's very important for a good game. Actually, what we have in these slides is that rules make the games fun. So, it might be kind of crazy to think about, but without rules, there's really no game at all. That's basically just doing, imagination instead of a game. So that's how you know how to play the game, is with rules. Can you name any games from the rules from the games you suggested earlier? I know Wei says GTA 5 might be a fun game. And definitely in GTA 5, there are certain physics that you can't violate. Like you can't just fly away. That's definitely one of the rules in GTA 5. You can't just fly. And money can also be something in GTA 5. So that would be another rule. You need to have enough money to do something. But we're going to talk about a much more basic game, which is tic-tac-toe. And with tic-tac-toe, you start your turn and you can basically do anything, right? I mean, you can put an X in any box. You can put an O. You can even put an emoji. But actually, you can't really do these things, right? These are actually not rules at all. You can't turn tic-tac-toe into a birthday cake. So rules basically tell us what we can and can't do. And so tic-tac-toe, there's actually one rule, which is you can only put X and O symbols in unoccupied boxes. And this is why rules matter, because your friend would tell you to stop if you tried to turn the board into a birthday cake, or if you erased their O and put an X, right? Because you've agreed on a set of rules and you can't violate those. How else would you choose a winner, for example? Luckily, computers are really good at rules, so we can definitely get our computers to play with us in our games. And to do that, we'll talk about some basic computer science principles. One of them could be the state. So the state is actually what's happening right now in our game. So we could store information in our computer about the locations of X and O's on our board. And state is actually what makes these video games work, because the game needs to look at a current game state and apply rules based on it to choose what happens next. In tic-tac-toe, the same rules apply each turn, although that's not necessarily true for every game. It's true for many games, especially simple ones. And the computer is going to look at the state to decide whether you're allowed to make a move. And that's considered a rule. Let's talk about the game loop now that we've talked about states. The process of applying the same rules each time is called the game loop. And so the game loop is going to look at the state and determine what it should do next, applying the same rules every time it does that. In tic-tac-toe, the computer will see this board and say, wow, actually, we could put an X in any of these spaces. And once it's done that, the state has actually changed. But the game loop doesn't necessarily have to change. It can apply the same rules. So for example, you could put an O somewhere to try and win, repeating over and over again, hence why they're called loops. Eventually, one side will win the game, or there could be a draw. And the computer will tell you when this happens, because there's a specific state associated with winning and drawing outcomes. All right, so enough about tic-tac-toe. Let's build a different game using some code. We're going to build the game rock, paper, scissors. Very common game, pretty much known all around the world. Very simple, and actually the same rules apply to every state, which is why it's a great analogy for our tic-tac-toe. Yeah, if anybody can confirm whether the audio on this stream is breaking or maybe there's some issue, please let me know. There's not much I can do, unfortunately, about my internet. One thing I can do is turn off my camera, which could help. So if anyone else can confirm that, okay, great. Yeah, if we run into, if a couple of people report audio issues, I will be happy to turn off my camera, which could perhaps make the quality a little bit better. But for now, we'll just keep going. So everyone, please head to this link, the one that we have on mlhlocal.host. I just put the link in the chat also for you if you want to take a peek. Let me actually share. Oh, I did not mean to do that. Let me share the next slides with you. So actually, when you go to this glitch website, you're able to sign up, and that would let you save your code, but it's not necessarily required to sign up. you can remix the code, which means that this starter code we've provided for you, you can add your own style to it and add your own code, which is exactly what we need to do for this workshop. And then you'll be good to go. So actually, let me do this live for you so that you can see exactly how to do this. Let's share my glitch. Okay, so you'll see this rock, paper, scissors, shoot. It's written by Jamie Wittenberg and Mara Lee Hart. And you can see that there's this base code. We'll click View Source. It shows that we have some base code for our workshop. And we can click this Remix Your Own button. That will actually give us our own version. And once you click this remix, it can take some time for a glitch because it's copying all of the files onto your local account, or not your local account, but like your account. And this is going to actually be something you can edit. So I could add a comment up here, Steven's remix, and that will save. A little bit of a glitch tour, which we might get to already when we go ahead and go through these slides. But just to give you a tour, these logs are pretty good for finding out where your code might be tripping up. And you can also use this terminal to run files. So we can actually do Python 3 and then do game.py, and that should run our code. It did, in fact, run it. So that's great to hear. You just need to use the terminal button at the bottom left-hand corner of your screen to get that going. And finally, if you want to show your code to someone else, you can use this share button, and you're able to actually share your project. You can share the live site or the code. Today, I think probably sharing the code is best. Okay, let me go back to the slides now that we've done a little live demo and see if we can make some progress on this rock, paper, scissors code. Before I continue, I want to say that if you have any questions, please send a message in Twitch or YouTube. I'm happy to go over them. I feel like I've already seen a few questions and have been able to answer them. There's one question about this that I didn't answer before that I think maybe I'll get to now, is what stacks we're going to use today. And actually today we're not really going to use a full stack, which is to say we're not going to go ahead and make a web interface and a backend for our code. We're just going to be doing some Python coding today. So we'll go ahead and answer your question. Okay, so this is your code. Like I said, your remix is for you to use. Don't worry about breaking it or anything like that. And one final heads up is that learning code can definitely be difficult, but we're going to go through this project together. So please ask your questions. That's kind of what I was trying to convey with my comments just a minute ago. Mistakes are totally okay. Actually, mistakes are pretty much the foundation of a hackathon. So we're all about mistakes here at MLH. So how does this work? There's a few different things going on with this code. We have a sort of an interpreter in this terminal that lets us run the code. And when we run the code, we get these inputs. We get a question like, what move do you want to play? And you can choose rock, paper, scissors, shoe, and it will give you different outcomes based on those choices. So what is this? Well, this code over here is part of your Python code. Can you find this in your own glitch? Let's see if we can in our live demo. Okay, so here's our live demo. Actually, that code should be somewhere around here. I think this is it right here, the while not statement. I could be wrong, but I think it's right here on line 86. And so this is actually Python code that forms some of the building block of our game. It says in this comment that this is our game loop. So a while statement indicates a while loop, which is basically a repeated part of the code that will repeat until some condition is satisfied. And so in this case, the condition, the code will keep repeating until there's not a winner. So winner might be some kind of Boolean variable, meaning it might be true or false. And then when winner is true, we actually will see the while loop stop. So once there's some kind of winner, the game will end, which makes a lot of sense intuitively. Hopefully, you played enough games, once there is a winner, you pretty much stop playing the game. Okay, so let's go back to the slides. So what is Python? I mean, I just talked about Python and gave some examples. It's actually, believe it or not a snake, even if you might think so. Although the logo for Python does have some snakes in it, which I think is pretty cool. One of the coolest coding logos, I think. You can use Python for a lot of different things. It's really one of the most popular coding languages that we have in the internet community. And you can use it for lots of different applications, including building games. So if you remember the game loop, like I explained, this while loop is going to check whether there's a winner. And until there's a winner, it'll keep applying these rules to the state. Inside of this loop, we have a bunch of code. And the way we know that this code is what's executed inside of the loop is that there's a tab or some spaces to indicate that fact. And we call that indentation. So this indented format shows us where the code is that gets repeated over time. When does the loop stop? It's like I said, as soon as this condition is met, it will stop. So let's recap really quickly, because I went through a lot of information there. Basically today, we are going to program a game using Python. Our game is going to run in a loop until some condition is satisfied. And once that condition is satisfied, the game will have a winner. But how do we know when this is going to happen? The way we know is that we're using the rules of the game. So one of the rules of rock, paper, scissors is that each player makes their move and chooses rock, paper, or scissors. So our code tells the game to follow those rules. You can see on this first line of the while loop that the player move is one variable and the computer move is the other. And so these are going to be where we store our moves. And then the state gets updated later. Both player move and computer move are stored values that are returned by a function. And these two functions are called ask move and make move. We haven't talked about functions yet in this workshop, but a function is basically a block of code that tells our program to do something specific. It's kind of like a recipe. If you think about a recipe book that has lots of different components to it, one of the components might be whisk an egg, right? And whisk an egg is just a small sentence, might be kind of like a function almost. And you actually know that to whisk an egg requires several steps. So every time they write whisk an egg in the recipe, you know what to do. And that's similar to a function. And the output of those functions, in other words, the outcome, in my analogy, the outcome might be some kind of egg batter, and you would want to store that somewhere. And so you could store it in these variables called player move and computer move. And variable is another term that we haven't defined yet, but a variable is something that stores a value, like a number or some text. It's really similar to math, where you can say x equals 5. Here you can say player move is equal to the outcome of this function. There's multiple types of variables. I talked about 2 examples. You could store text in a string variable. That's just a name that is pretty much universally used to describe kind of a set of characters. And you can also store variable information as integers. So an integer, if you're not familiar with that word, basically just means it's similar to a whole number. So like 1, 2, 3, or -3, those could all be examples of integers. Yeah. So yeah, I mean, this emoji, they use this emoji a lot in these slides. So there's a lot of mind blown going on here. But if you have any questions about some of these things, I'm happy to stop and pause, talk a little more about functions or variables, or even to talk about the code and how it works. But if not, we're going to continue on and talk about the rules of the game. So let's dive in to a particular rule, which will happen in this line that's highlighted here. Okay, so in that line, we saw player move being a variable that stored the outcome or the return of this ask move function. So the function itself is actually defined in this block of code. The way we know that this is the block of code that defines the function is because it has the function name at the top, where it says ask move, and there's a def in front of that function. So that is indicating to the program that the ask move function is defined below, and the details of that function are shown through indentation. There's a conditional statement here, which shows that if a move is not in a set of valid moves, there will actually be a print statement that says this is not a valid move. And if it is a valid move, then it will return move. Does anyone want to give an example of a valid move or an invalid move in the chat? Okay, okay, looks like someone saved me. Nice job. Thank you. Those are totally valid moves. And some other ones would not be valid, like maybe pineapple or something. X on top of O. Yeah, that's a good example for the tic-tac-toe game. That's a really good contribution. Thank you. Thank you for that. So if you remember conditionals, they're going to tell us about this. Okay, if we talk about if statements a little bit more in detail, an if statement is telling us whether something is true or false. And so this if line here, starting with if, it tells us basically this condition. And if that is not true, in other words, if we do get a valid move, it'll return that move. Someone says, so valid moves already defined before as variables. That's exactly right. If you look at this first image here where it says, this first line of code at the top right hand of this slide, it says valid moves equals, and then it gives a list of strings. If you remember, strings are these groups of characters in order. And so it shows you rock, paper, and scissors. Those are actually already defined in the rules of the game. And so that's a good question. Definitely good to point that out. Boolean is basically another type of variable similar to strings and integers. They can be stored, and a Boolean is actually what's put next to this if statement. So move not invalid moves can only be true or false. Either the move is in this set of rock, paper, scissors, or it's not. And so if it is, it's true. If it's not, it's false. And that's exactly what a Boolean is. So what exactly is our if statement doing? Again, just to reiterate this point, our if statement is checking if the move that was entered by the user when it asked for an input is contained within this valid moves list of different strings. And if it's not, which is the first condition that's checked, it will print out that that's not a valid move to the user. And if it is, in other words, else, then it will return the move that the user gave. And that's basically what a rule is for a game. It's going to require you to do something, require you to choose rock, paper, scissors. You can't choose birthday cake, for example. And building a game just involves putting so many of these different rules together in really detailed and comprehensive ways. So now that we've looked at building rock, paper, scissors, let's look at our AI-based opponent. So we're actually going to build today an opponent for us to play rock, paper, scissors against. And in this example, with an AI-based component, the computer will make a move too. So computer move is the line just below player move. And unlike player move, where we're asked for an input, the computer move is going to have a different function called make move. So now the function is going to generate a move for the computer to do. Before we look at how our computer decides what move to make, how would you decide to make a move? I'll give that to you as kind of a rhetorical question because it's kind of a complex question. But if you want to give your suggestions in the chat, please feel free to do so. How you might program an AI to run rock, paper, scissors. But this is how the computer decides in our example. So it's kind of a funny way. So it will define make move, and it will take a number equals lens state mod 3, do this catchphrase thing, define a move, and then return that. So this is kind of like really strange. And we'll break this down a little bit. So where is this number coming from? We use the length of our game state to decide which move the computer should play. This means this computer will cycle through different moves, rock, then paper, then scissors. So someone says, maybe we should do this randomly. And I think that's probably the best strategy for some fair player. But maybe there's some other ways, honestly. Of course, if you know what the player is going to play, then there's a really good move, which is the winning move. But yeah, that's a good strategy, I think. Randomly is definitely a good one. So the key here is that there are actually multiple moves. It's not just that there's one possibility. There are 3 different possibilities in the example for rock, paper, scissors. And so we have rock, paper, or scissors as 3 separate states. That's enough talking. Let's play a game of rock, paper, scissors. So let's play rock, paper, scissors. Someone says, just asking, these are just rules. What's AI about? And that's a really good question. So we'll talk about this a little bit more. But basically, an artificial intelligence is really there are several meanings to the word artificial intelligence, and one of them is really just about conditions. Not all artificial intelligence revolves around machine learning. Machine learning is like a subset of AI. So we're not necessarily going to talk too much about that today. But yeah, we'll get more into this concept of AI and what exactly is AI later on in the workshop. But for now, let's play rock, paper, scissors. So you can run this game in the terminal, just like I showed you in the live demo portion of the workshop. The way you'll do that is by entering a command called Python 3. And Python 3 command tells the terminal to interpret a Python code. And the argument that's taken by this Python 3 command is the file. And so the file, there's only one in this workshop, and it's called game.py. And so we will do Python 3 game.py, and that's going to run the Python code. So here's just a GIF that shows you a possible way to play. And so you can type in your move, and the AI will tell you bazinga, and then basically you'll either win or lose. So yeah, as you can see, over the course of this animation, the player gets a lot better at beating the AI. But yeah, so there you go. Okay, now this is just kind of saying what should be the catchphrase. And actually the catchphrase here is bazinga, not cowabunga. So I think there is a bit of a typo here in this slide, but let's fix this. We gotta give our AI a different catchphrase. So we can update our cowabunga to any other variable. We can change this string to bazinga or to whatever we want, and it will send a new message from the make move function. It just shows you how to do that. We can have multiple catchphrases if we want and learn a little bit about multiple variables at once. So let's actually put some new catchphrases in to our AI here. So hang on, let me do a live demo for you so we can actually put some new catchphrases into our Python. Okay, so if we scroll down, let's see if I can zoom in at all. Maybe that'll make it easier for you to see. So the catchphrase is currently bazinga, but we can update this to have multiple. So the way we do that is by forming a list. Right, bazinga, right, cowabunga, right, take that, I don't know, take that. Okay, so there's some, and they suggest that we change the name of this variable to catchphrases, which I think makes a decent amount of sense. Of course, now if we print catchphrases, it will actually print multiple values. So we need to tell which value we want to print exactly. Does anyone have a suggestion about how we could print some kind of catchphrase? Okay, so maybe I'll give us one. The idea we could try is to use this number index to print a different catchphrase depending on what the AI chooses to play. So that could be a good way to do it. Yeah. Oh, yeah. We could totally choose a random catchphrase too. This AI is pretty not very smart though. I mean, it just basically goes through and picks these in order, not necessarily randomly. But we can change that if we want. Okay, so now that we've got this, let's see what happens when we run our code. So when we do this, I rock, I lost, and it gave me cowabunga. So basically this one played, it definitely played paper. So let's try another one. I rock again. Ooh, now I won because I knew that the AI was going to play scissors. So I won actually. Now I can try paper and I can just keep winning this way. Pretty cool. I beat the computer. It did not have a very good AI algorithm. Pretty weak. Okay, so now you kind of get the idea behind this whole catchphrase thing, what they're trying to get you to do here. And actually, this is why computers are kind of dumb in a sense, because they'll do anything you tell them to do. And, I mean, if you tell them to play this way, they'll do it regardless of whether they win or not. So there's another caveat to this, which is that computers can't understand anything if you make a typo. So let's look at some examples of common typos with code. One common typo is any opening brackets need to have closing brackets. And if they don't, the computer really does not understand what you're talking about. Another common one is quotes, where you have to have two quotes to write a string or something of that nature. And another one that's very specific to Python is that you need to have correct indentation. So like we mentioned earlier, the contents of a loop or a function are noted in Python, not using some kind of brackets like is common in other languages, or semicolons or anything, but they're really the key feature is indentation. Okay, now we've checked for pesky typos, and we can see our new catchphrases in action. So actually now everything should work out just fine for us. But this AI is kind of boring, right? I mean, we coded basically this one, which goes just in order, and it's pretty easy to beat it once you realize what the rule is that it follows. Or I'm sorry, not the rule necessarily, but what we tell it to do. So let's make this code a little bit smarter and add to our artificial intelligence. So rather than just looping through the different moves, let's make this code beat the opponent's last move. And that way, if they try to be sneaky and repeat the same move, then the computer will win. So this could be a good strategy for our artificial intelligence. So let's get ready to edit this function now. We can comment out the move variable that we used previously and add a variable that gets our last move from state. So if you remember, this state is telling us exactly what the game looks like at any given time. And the state from the previous case would be indexed by state -1. So we can get that. Instead of valid moves number, we'll use state -1. The other thing we're going to need to do is add an if statement, which returns the move, which would beat the player's last move, not the last love. That's a typo. But the idea here is that we will have these three conditions where if the last move was rock, then we'll play paper. If the last move was paper, play scissors. And if the last move was scissors, which is the only other possibility, so they just wrote else here, then we'll play rock as the AI. So this is kind of new, right? This idea that we would use the last move from a state. And we're using an index to accomplish this, just like we did for choosing our catchphrase. Indexes with a -1 are the last thing in the list. So we have a list of states, and the very last one, we can find the length of the variable and all that stuff. But the easiest way is just to find it using -1. It's kind of like a shortcut. So now that our computer has big brain energy, let's see if it works. Let's actually do this live. We'll do a live demo of this, editing this code. So I'll show you exactly where to go to do this. And the way we need to do it is by accessing this make move function. But there's going to be a slightly different part of the code that we'll edit. We're not going to edit the catchphrase lines. We're going to edit the lines involving the move, which are these last two. We comment out the move, and we actually put in a new variable called last move and state -1. This is going to now store our move, the last move, not necessarily the move, but the last move that the user made in this variable. And that value is going to be, does anyone want to guess what the value will be, what kind of type it will be? Will it be a string or will it be an integer? I'll give you those two options. Okay, someone says a string. That's correct. So the last move will be a string. And the reason we know that is because the moves are stored in this code called valid moves up here. And all of these list items are strings because they have quotes around them. They're groups of characters in an order. So they are basically strings. Okay, so that's great. we have this last move thing, and now we have to build this conditional, the one that will basically form our AI in this case. Now we're really getting into the definition of an artificial intelligence. So basically, an artificial intelligence is just something that is going to actually, maybe we can look at like a Wikipedia definition, because those can often be pretty valid or pretty useful, I would say. Okay. So an artificial intelligence, it says here, is any system that perceives its environment and takes actions that maximize its chance of achieving its goals. So in this case, we are having a function called make move, which is basically our artificial intelligence. It's perceiving its environment, meaning that it's checking what the last state was, and it's taking an action to do that to maximize its chance of winning. Now, in this case, maybe this strategy really is the best way for the AI to achieve its goal of winning the game. But it seems like maybe we would need to use another technique to truly optimize. That being said, any type of system that is built in this way would be considered an artificial intelligence. We don't need to use any kind of advanced statistical technique to construct an artificial intelligence. It just needs to be a system that's designed to take actions that maximize its chance of achieving its goals. In other words, like in this case, it is achieving the goal of winning the game. So random could be a good strategy. Maybe that's actually the best strategy, or maybe it's this strategy. It's hard to say. It's actually probably a very interesting research question. Okay, let's go back to our code and build out our artificial intelligence. So we have to write this algorithm here, which will be based upon the state of the game. So we will start with a if statement. And remember, if statements operate on Boolean variables. So we have to put a condition here that's going to actually give us a true or a false value. So one way we can do this is by saying if the last move is equal to a rock. You might be wondering why I put two equal signs there. It's not a typo. It's actually showing the comparison of last move to this rock move. Put a colon and then enter. The enter actually already puts the indentation there. You can see where our cursor's further in here. So that's actually pretty good. And it might say to return, or we could just write move equals paper. So the move would be paper to win that game. Elif would consider another possibility for the conditional. So we can say else if last move is equal to scissors. And in this case, the best move would be actually to do rock. And finally, if neither rock nor scissors are played, the only other option is paper. So if paper is played by the user, the winning move is, of course, scissors. So now we can basically beat the last move. And so if the player plays the same move twice, this computer simulator will win. Okay, so that's great. Let's try this game. So we go back to our terminal and we can use Control-C to quit out of our old game. You can see I just did that, and let's run again. This time, if I choose scissors, let's say I win this game. Oh, I drew actually. That's right, because he was going to play scissors first. Okay, that's fine. But let's say then I play again with scissors. Actually, now I'm going to lose because the computer is going to choose to play. It's going to choose to play rock. So there's a good example how to of this artificial intelligence algorithm in action. Okay, back to our slides here. Yeah, so you can actually see now that if we play rock so many different times, we'll lose every time. And so this computer now has a bigger tactic, but it's very predictable. So unfortunately, the player can easily figure out what the computer strategy is. So now we can maybe make the computer only try this strategy sometimes. And this is how we're going to get to what a lot of people have suggested, like Captain Pineapple has suggested, and some others have suggested to use randomness, built-in randomness, to make our artificial intelligence a little bit smarter. So we're going to use this function called randint. And this way we can write if random.randint equals 0, it's going to execute this strategy. And otherwise, it might just do something else. So let's make a randint. We can do that in our code. What it's actually doing here is drawing upon a function that's already built into Python called this random function, and saying that basically it will flip a coin and do 0 or 1. And by flipping a coin each time, the player never actually knows what the computer is going to do. But there's this other else that will happen, and we're going to look into that now. So we can use Google to get a random item from a list. And it's very similar to actually to what Captain Pineapple suggested here, to use this random type function. It's actually called random.choice in Python. So we can just pick a random move. So half the time this computer is going to play a random move, and the other half of the time it's going to play the move from the last one. And this is kind of an interesting game, right? So it's getting a little bit interesting. This strategy, much more interesting than our first go at this. So let me go to a live demo of this, so that you can actually see how to do this live. If anyone has a question about what we've been doing so far, please send a chat. I am happy to look at those. So we have this this algorithm here, which tells us to basically play the winning move based on the last move. And so we only want to execute this half the time, right? The other half of the time, we want to actually use a different algorithm, which is just going to be this random.choice, which is going to choose from the valid moves. It's just going to pick from the valid moves and say that should be the move. So the way we can separate these is by using an if statement. So we can write if random.randint, and then we can use this 0 and 1. So it's going to pick an integer between 0 and 1, only 2. So it's kind of like flipping a coin. And if it's equal to 0, then we will have all of these conditionals. And otherwise, we will need to put a random move. And you can see I'm actually, very deliberately choosing this indentation here to show that this outer conditional is on one indentation and the inner conditional is on the other, just to really make that clear for the Python interpreter. Okay, so let's see if this works. I actually think, is it random choice or is it random choices? Because in the slides we have random choices, but I think that's a typo. So don't follow the slides, follow this, random.choice. So now let's test our code. We can test it live to see if it worked. And if we play rock now, oh, we won, that's great. Let's play rock again and see what happens. Ooh, I won again. So actually, if you can see, that means this part of the code executed, not the first part. And let's just keep playing rock. So now I finally lose because either it chose a random rock or actually maybe this part executed. We can't really tell without putting some kind of print statement there or some way to tell which side of the loop is, or which side of the condition is being executed. But it's definitely working now. So now the computer is more difficult to beat. So we can actually use 8th grade math to figure out the conditional probability. And we have a 50% chance of the last move being played and a 50% chance of a random move being played. So we can make our code even more tactical and have it keep track of the previous moves. So we can update these 2 lines to write most common state and learn about basically what the user is playing most frequently. So to do this, just write most common, use that function for your most common state, and replace your last move, which was a kind of a simple code, with the most common. And now this is using a different type of for loop, or a different type of loop called a for loop, which is going to go through every possible state and figure out what the most common was. So we can test our code again, and this is just a GIF example. But basically here, it's going to learn about what your most common plays are, and that might be a really good way to beat you, because you're not a perfectly random player. You might have some bias towards one of the options, and the computer can now learn about that and actually beat you. Whereas a human might not be able to keep track of all your moves, especially if you play for thousands of times. So this is now becoming a really interesting artificial intelligence. So we've actually built a basic AI here. Even though a lot of people think about AI as this really complicated thing where we have, neural networks and things like that. Really what we're using here is just really basic statistics, like a random, to do conditional probability. We're using a mean, right? Or actually, I guess we're using a mode to figure out what your most common move is. So we're just using really basic statistics, and they can be really powerful in building a hard to beat AI. So now we've built a lot of stuff together, but it's your turn to write the rules. So I would encourage you to try and make this AI even more complicated by adjusting the frequency with which the computer plays a random move, maybe play the same move to trick them, do things like that. Now we're going to recap. So we'll use a quiz to do that. I will put a post to the quiz in the chat. So there goes your quiz right into the chat. Please click on that to take the quiz with me. I'm going to do it with you live. First, you need to fill out some basic information about this. Actually, there is no Python skills part 4. Oh, okay. Actually, I don't think we're going to do the quiz today because it seems like they have not created a quiz for this workshop yet. So sorry about that. We will not do a quiz. Okay, sorry about that, everybody. Should have looked at that beforehand. Okay. So, okay, so here's some other things you could try is adding a catchphrase to the computer and even giving the player a catchphrase, which could be kind of nice. And okay, this is what we were talking about before, about there's actually an optimal rock, paper, scissors strategy. Hint, it's not a random choice. So if you're playing against a human, it could definitely be advantageous to look into this paper to see. And maybe you can add some extra moves to your rock, paper, scissors. I mean, there's actually no reason why there can only be 2 or 3 different possible moves, right? We could build out rock, paper, scissors however much we want to. So There you go. There's some ideas for you. But anyway, that's pretty much it for today. And thank you so much for coming to the workshop, learning a little bit about, yeah, exactly what Dom Tran says. Those are some classic moves from rock, paper, scissors that I used to play as a kid. But anyway, I will see you in the next workshop. I wish you all really good luck on local hack day. And yeah, have a great week.